Okay, I think this thing is working. Okay, so I got Houdini here. And the first thing you want to do is you want to, once you have the Dune Solver downloaded, you want to, so this is just a brand new scene, you want to go up to Install Asset Library and make sure it's installed. And depending on where you put it in your folder structure, when you open Houdini, it might automatically find it and install it. You can check that by going up to Assets and Asset Manager, and then you should be able to search for just like Dune. And I think in this case you can see nothing comes up, but if something comes up, then it will point you to where it's installed. Otherwise, go up here to Install Asset Library, and you can say, install it just in this file or put it into one of the asset library directories so that it always becomes installed. Go over here. In this case, I'm going to go to, let's see if I can remember how to navigate to it. HDA folder where I have it downloaded. And I'll just do this one, I think. Accept. And you can just do install. And now it's installed. And now if we go up to Asset Manager and research for this, this should come up now. Current hip. Well, you can see it at least here. Let's see, Dune. Yeah, there we go. Now it shows up. So you can see it's installed into the current hip file. Now the way you want to set this up is first we will do a height field. You can just drop down a geo node by itself, but height field kind of works. Now in the height field node, one thing to note is a height field is made up of two primitives by default, and these primitives are basically 2D volumes made up of a lot of points, kind of like, think of like two grids of points, and so each of them stores a array, sort of like a grid array of float values. And we can actually, let me just make sure this isn't too big, so I'm going to set this to 100 by 100 and grid spacing of like 10, so this is going to be a really low res one. And then if we turn on voxel data, you can actually see all the data stored in every single voxel. You want to be a little bit careful with this, because if you have a really dense grid, it will, or a grid with a lot of voxels, it can take a long time to populate this. So, but turn that off, and so you can see voxel resolution. So see, it's 10 by 10. One thing I like to kind of turn on sometimes is there's this volume max value and volume min value. Those are kind of nice to sometimes keep track of what your volumes are doing. But anyway, let me get back to just making this a simple intro, and then I can get more into the specifics later. So in order for the Dune Solver to work, we need a little bit of additional layers. And the way we are going to do that, the main layer we need is a sand layer. And so we can create that by saying copy height field copy layer. So that's going to take one of those two height field layers that are created by default, either the mask or the height, and create a new layer that we will call a sand. And so now we have a sand layer. It's an empty sand layer. The source was the mask. In order to make that, to give that sand layer some value, we can actually just we can do noise. We can do height field noise, and we can add that noise directly to the sand layer. And let's make sure it's adding and that we're not centering it, and we can adjust it here. We can look at the height and adjust it, or if we set this to sand, what's going to happen is we don't see it anymore. It's still doing it. If we look in our geometry spreadsheet, you can see that it's still affecting our sand layer, but it is no longer visible very well. If we want to view it, we can do height field. There's some visualize, height field visualize, yeah. Actually, no, we want isolate layer. So isolate layer. Height field isolate layer. This is a quick, easy way to see a layer. So we can isolate the sand layer. And now you can see what this sand layer is doing. Yeah. Element size, so we can, the amplitude is like how deep it is. So, we can just do like a lot of sand. Anyway, now if we just plug this into the Dune Solver, it should work. So this is basically just like added sand on top. And it might take us a little bit to calculate. Oh, oops. Let me save this somewhere. Okay, let's see. Visualize. Why is it not working? We might need a, I think, sorry, I'm not used to doing this without the setup tool, but let's add another layer. We're going to do bedrock. And I think this will probably help. There we go. And we can also, so now I believe this will start to work right now. There we go. And we got it working. So this is like the very bare bones, is you need a sand layer and a bedrock layer. And basically the sand gets added on top of the bedrock. If you want to have a bedrock layer that isn't perfectly flat, then you want to add some noise to that. Height field noise. And we can just put this here. And let's add this noise to the bedrock. And again, if we do this isolate layer and pick the bedrock, then this will be the bedrock here. And the bedrock can be, I believe the bedrock can be negative, so you should be fine with having some negativeness in the bedrock. You can increase the size there. Yeah, so that gives kind of an interesting bedrock. Change the offset a little bit. Get some different patterns in here. Yeah, so we got our bedrock, we got our sand, and our sand, let's sand's down here. Let's change the noise for the sand. We could do like a crazy alligator, do some like piles of sand like this. And then, obviously this is getting a little bit hard to visualize. So the way I like to visualize it is with a height field visualize. And actually one sort of issue is the end result, the end result of the Dune Solve is basically the sand plus the bedrock. So it takes the bedrock, it puts the sand on top. And we can do that with a little bit. You can do this a bunch of ways, but the easiest way is probably with a volume wrangle. And just a tiny bit of code, and then we'll basically get a really good preview. Or actually, no, maybe, how about a slump? I think we could do this with a slump. Slump node might work well too. So plug this into here. And again, we can we can see now we have, yeah, so we've added we have the height, the mast, which are the two default ones that come in from the height field node. Then we've copied them, added the sand and the bedrock. Then we've populated them with some noise values. And now we're going to slump. And I think the slump has some nice options to, we're going to turn off this flow field. See these like flow directions, they come from this. We don't need those. And so this slump node has some nice features where we can set the bedrock to be bedrock. This is kind of where I got the name from. And then we can set the material to slump to be sand. And I believe flow field. And then, yeah, we can add the material to the bedrock. So if we have the, so this will add the material to the bedrock. And then if we isolate the bedrock, this is basically where we're going to get. So you can see now this slump node is adding the sand to the bedrock to view it. So that's one way of viewing it. And then you can even set a repose angle, which is kind of similar to the repose angle of sand, which is about 30 spread iterations. So now we have our piles of sand. So you can do it that way. The other way you can do it, if you want to do a wrangle, is you can just simply say f at height equals f bedrock plus sand. So this is because the sand is going to be on top of the bedrock. And this will give the same thing, but it won't be slumped. The Dune Solver itself will be slumping it over every iteration. But so you can see, that you get something pretty similar from these outputs. Obviously, no wind or anything has been taken into account yet, but and then we still don't have a good colorization. The way you can colorize this is with just a height field visualization. And again, like if you want, there's two helper HDAs that you can install alongside this on Orbolt that are both free. And I might work on a HIP file that has them embedded. But there's two helper ones called Dune Setup, which does a little bit of the setup stuff, and Dune Smooth that kind of does a little bit of a post smooth, which I can go over. But this video example here is just meant to show how to set this up and use it if all you want to do is use this Dune Solver HDA. And you don't want to mess around with the others. And it kind of gives a glimpse as to sort of how the others work and what's going on under the hood. So this is just the normal height field visualization tool that comes with Houdini. You could say like compute range or something. Gives you this like gradient across it. The key thing is you want to set one of these to like sand. And you set that to sand, and immediately you can see, oh, that's where the sand is. And you can, if you want to make this a little bit more like bedrock, we could delete these. And so now you have the gray for the bedrock and the orange for the sand. And this will, this would work here as well. Yeah. But anyway, that gives a good way to do it. And so you can see these things that I did where I'm setting the height to be the bedrock plus the sand. That's happening within the Dune Solver. So if you just add the Dune Solver, you kind of see that here too. I think I have a colorize. Oh yeah, actually, never mind. I also have this like colorized, so you can just turn on this colorization. The gradient's a little bit is a little bit off if your train goes into the negative, but anyway, it gives you a little something. I think that's because up here, if we turn off, if we turn off center noise, so that our train is all in the positive. So you can see here in the geometry spreadsheet. If your bedrock goes into the negative, then it kind of gets cut off. But if you keep it all in the positive height, then this colorized thing should work great. Yeah, let's not get that. And now I think we could just play, and we get some dune movement. And you can see, a big part of it is there's wind, and so there's wind blowing. And you notice we never set the wind direction. And that is something you can set a bunch of different ways. If you get the Dune Setup tool for free on Orbital, then that comes with like a wind setup. But we can also set a wind without that. And there's actually this little hidden thing they haven't shown yet called windrows setting. And so we can actually feed this Dune Solver a windrows, which might be the easiest way to get a quick direction. The way you can do that is just, let's do a point maybe. Point, I think it's add point. Add. Maybe it's just point. I forget how you add just like a single point. Oh yeah, here we go. You can just add a, no, I guess we, point, make point generate. I know there's some simple way in Houdini to generate a single point. Add, okay, that's what it is. So we add a point, and this point, you'll notice this point is, make this visible, is just at 0, 0. If we transform, I don't know if people know what a windrows is, but it's kind of like used in weather to show how frequently the wind blows in different directions. And I have this little second input called a windrows, and you can put a windrows into it. And your windrows could be a circle, it could be a single point, it could be multiple points. Basically something where we will scatter random points on that windrows shape and generate different wind directions based on it. So if I move this point, off over here, now that means the wind will blow in that direction. And we can visualize this with the Dune Solver by turning on this visualize wind trails. You'll see they're kind of going all different directions, but maybe we need to, we need to update a little bit first. Or, oops, maybe this needs to be a circle after all. Let's make this windrows a circle. And we'll set this to polygon. Sorry, again, I'm not like super used to setting this up without the setup tools, but it's been a little while. Okay, this should, okay. Oh, I see, it's the, should be on the XZ plane. There we go. And then this transform, just move it out over here. And now, let's see if we move this over here. Okay, never mind. We're going to set this up a different way. We will set this up with a volume angle. And for this volume angle, we're going to, well, first we need to set up the wind layers. So we're going to do another one of these layer copy nodes, and we will copy from the mast into wind v.x and wind v.y and wind v.z. Okay, so now we have a XYZ. And now you can see in here, geometry spreadsheet, we've got wind. So this is basically a three sets of floats that make a wind vector coordinate that goes across the entire scene. To do that, we are going to use, let's add, let's just keep it super simple for now, I guess. And we'll take, so we're going to do V at wind V, and we're just going to set this into channel vector, wind vector. So this is just making like we're just going to set that wind vector to whatever vector we make here. And so you hit this thing and it will make this vector for you. And now we can set this vector, we can have it come from the positive Z direction. And now, the wind is blowing in the positive Z direction. If we want it, like, I think this one might look neat if we blow the wind. Oh, that's a pretty good direction. But you can change the wind, and I think it's fine if it's not normalized. Right now it doesn't pay attention to Y, but in the future it might. But if you play it, if you have it come from, so now it's coming at a diagonal, X and Z. So you can change it that way. The other way, if you want it a little bit more interactive, rather than typing different values in here, you can use that add point thing I was showing earlier. Set a point and feed this into maybe the second coordinate thing, and then we can say V at wind V equals point, and we can just read the position of that point. So 1 for this, these inputs are numbered 0, 1, 2, 3. So we're going to do 1, and then we're going to do V at P, I think. Wait, I always forget the syntax of these. So geometry, string attribute, point number. Okay. So I think we want P for position, and then point number 0 because there's just one point. And might as well normalize this. There we go. And now I think if you can kind of see this working here. Yeah, so as we move this around, and now we should see, if we check this geometry spreadsheet, yeah, see now we're getting a wind vector from that point position. And so now the wind will blow based on where we place that point, which is kind of a little handy interactive way of doing it. One thing you might notice that might be looking a little confusing is the wind. If we look at the wind trails now, the wind, it's not going that much in one direction, and that's because the default settings warp the wind quite a bit based on the height. And so if we turn these off, you will see the wind is straight, going straight across there, and that will give you, if we move this point, yeah, really nice and interactive. And the wind is blowing in the direction of the point. So the wind's blowing from the center towards the point. So if I move the point over here, now it's this way. Yeah. And now we can go back and let's turn on that colorization again and play it. And now we got some sand piles blowing across, and eventually they'll start forming what looks more like sand dunes. And you can see, this is simulating in real time. It's very fast. This isn't like the most dense grid. It's 2 million voxels, but yeah. I hope that at least like helps people get started with this. Where to go from here, you can, there's lots we can tweak. Let me just tweak this a little bit so we're getting something that looks a little bit more like normal sand dunes. Normally sand needs a little bit more of a flat area to really start to form some dunes. But so we're going to go to the bedrock here and lower the amplitude. And you can see it's all updating pretty nicely now. Maybe 300. Now element size. So the bedrock, and then we're going to. This is the noise for the sand. Still, I kind of like the alligator noise for these sand piles. Let's try keeping some sand piles going. And yeah, let's see how that looks. Yeah, I can see we're starting to get some sand dunes now. Some of those crescent shaped dunes. Yeah, I think that's the basic setup. But now I will go into a little bit more like how to change the look now, I think. And sort of refine it. We're getting shapes, but it's a little rough. So how to refine it. Will be next. Actually, I think we need a little more sand first. One thing we can do here is we can set a minimum sand. So let's do a minimum of 1 sand and a maximum of 10, maybe. And actually, I guess those minimums are as a percent of that. So I guess what we want is like, let's set this to maybe 50 or 30, and then let's set this clipping minimum to be 0.1, so it'll be 10% of that maximum one. There we go. So now we still got some sand piles, but we got sand everywhere also. And then as it blows, yeah, I can see we're getting some dunes. The way we can refine this, bunch of ways. Go into our height field. Right now the grid spacing is at 2, so each sort of effective grain is 2 meters if you're using the 1 unit equals 1 meter. Let's set this to 1. That immediately gives us a little more resolution. The other thing you can do if you want to refine this is this grain height ratio. This is sort of like how much sand it's moving each iteration. So we can lower this to, let's say, 0.2. And the more you lower this, the slower the sort of the movement will be. So you can see, it looks like it's really slowed down. It's simulating at the same speed as if this was higher, but it's moving less each time, so it looks like it's slowed down. Yeah, but it does. So if you get this smaller, you can see this grain here, and unfortunately the ways to get rid of that are to increase the sim resolution, to decrease this, or to do a bit of post smoothing. I will decrease this, and yeah, I can see it's a little smoother. Probably one of the best ways of working is to kind of take it in steps. So think about it as first you're going to get your big shapes in, and to get your big shapes in, you can even increase this. You can even go like 0.6 and simulate this for a little while, and this is going to get you some really bigger dune shapes, especially if you're starting from someplace like this where you want like quite a bit of dune evolution. So we're going to start with that like pretty big, have this go for a while, and maybe like frame 200 or something we'll stop it at, and so we'll put a time shift down. And this is a really super helpful node to to kind of like freeze the simulation on a certain frame. And so right now you can see it's cooking. There we go, cooked to frame 200. Still very fast. And now what you can do is just put down another Dune Solver and do like a refinement solve on top of this. Oh, it's trying to calculate all the way to frame 60 though. So the time shift basically freezes the simulation in whatever frame, but now you can go back to frame 1 and then drop another Dune Solver after it. And then for this Dune Solver, if you get this red button, you can just like reset. It seems to work well. There's a seed down here, kind of gives you some change the randomization. There's also sub-steps, so you can, if you want, you can have this calculate multiple sub-steps for frame. So now we can lower this to like say 0.2, and that's probably the main thing. Lower that, and oh yeah, it has this wind warping defaults on again, so we can look at the wind trails and see what that's doing. And I don't know, I think it's kind of doing some nice stuff. It's kind of trying to use the height of things to adjust the wind strength. The other thing we can check is this height reference blur. So this is sort of like what it's looking at in terms of its reference height when it's trying to figure out how the wind moves over the terrain. And it's also what it uses for the wind speed, height wind speed, which is this, where it's trying to say like, hey, is the wind blowing faster or slower in different places? Because if it's blowing faster, that will change the shape of the sand dunes. So you'll get like a little bit more rounded tops to them. Yeah. Anyway, let's simulate with this. I think this will be pretty good settings. And you can see it's if we let it simulate for, actually let's lower this even more. Let's do 0.1, and let's go just jump to frame 120 then. It's actually a little faster, I think, depending on your settings, to jump a few frames ahead than to watch it play. You can see it's pretty fast. We're at 11 million voxels now. And so now you can see it's kind of refined some of that grain away. Yeah, so this is the same resolution voxel grid, but just now this is without the extra sim, and this is now with the extra sim. And you can keep going further. You could resample this height field and then put another Dune Solver after it. You could get this really super refined, but it will take longer and longer, which isn't necessarily the best for a live stream video. So instead, I'll show you another way to kind of get rid of a little bit of this grain stuff, and sort of help out with the sand dune shapes. And that is, we're going to do a slump. First we're basically going to do a slight slump, and I think we'll do a blur also, height field blur. These are this is kind of the same technique that you'll find inside of the Dune Smoother. So we're gonna smooth the sand a little bit by, just a little bit of a radius of 1. And you're not going to see this unless we do an isolate layer. Isolate sand. There we go. Override mask. And so blur with no blur. So we'll blur it a little bit, and then we're going to the reason you don't see it here is we're just looking at the height field, and so we're not recalculating the height field. So if we recalculate the height field by doing a wrangle, volume wrangle, and we'll just recalculate it by height equals, I think we can even leave off the F, sand plus bedrock. I think I do need the at though. Yeah. So now you can see this blur is doing something. And so if we blur this a lot, whoa. And you'll notice like, oh, well, why is that still looking noisy, even though it's blurred? And that's because that's the bumpiness from the bedrock coming through. And that's where this re-slumping it will help in a few ways. So for the layer bindings, we'll do bedrock, and sand is our material to slump, and we don't need the flow field. And let's not add the sand to the bedrock. Now you can really see this is doing a lot. And so let's turn off our blur and just focus on the slump. What you want to do is kind of set this to maybe like 12, depending, and spread rate, and just kind of play around with these settings a little bit. Maybe 16, and you'll see this. It kind of can smooth it while retaining some of these nice dune lines. And then you combine that with a little bit of blur, and yeah, it can help a little bit. Give a little post-process effect. So this is now and before. Well, you can, if you want to, also you can even do this kind of post blur and then run a Dune Solve on top of it. That can help. For now, though, let's go back and I will. I think the next thing I'll show actually is how to cache this. So, say you're running a Dune Solve, and you want to be saving this out to an external file. What you want to use is a file cache, and this is the way I do it anyway. You can run the Dune Solve into the file cache and just save that out. That can work. You can do that one or this one depending on which stage you want to cache out. The downside is if you cache this out, you'll be saving more than you need because you'll be saving all of these layers. And so what you can do is do a blast, and delete all of the layers except for the height one is probably the best. You could, you basically can either delete everything except for the sand layer or everything except for the height layer. I'll show you everything but the height layer. So we're going to do height, I think. Height. And delete non-selected. Oh, I guess I need the at. There we go. Name at. There we go. Yeah, so now we just have the height. And now if you look back in the scene view. So now this file cache will save everything except for the height. The question then is, well, how do you get the colors back and all that stuff? The way you can do that is by just grabbing back from the Dune Solver. So I'll drop a null down, because you only need to save the height every frame, but then you can use the, I'll show it from here, I guess. You can use this information to sort of rebuild what the sand layer is in the bedrock layer. Angle. I'll show what that looks like. So the way you would recombine these is, let's take the height from here and the bedrock from there. And so now we can say f at, so we're going to try and rebuild the sand. Sand. Oh, and actually, I should do this the other way around. I should do this into that slot and this one into there. So let's put these on the correct side. Hopefully this looks a little bit more organized now. So we got our blast, our file cache, and now we're going to reconstruct it here. So we got our f at sand is going to equal the bedrock. Well, we're going to do volume, and this will sample the volume. And so we're going to sample the other volume. So volume at volume. We're going to pick input number. I think this is what I want. And I'm not the best at explaining this under pressure. At P. And let's see, I think this is right. Volume. Returns the volume, yeah, variable containing P. Oh, actually, yeah, that's what we want. We want volume sample. That's why it's confused. Yeah, volume sample. And so we want it from geometry 1, which is this like second input down there. Primitive number, we can also use the volume name. So we're going to do height and then vector position. Yeah, there we go. 1, and at P, at the V, and from height, did I get these mixed up? Volume sample. I wish I could get this documentation stay up. Oh yeah, I reversed these. So we want height and then add vector at the position. So this right here is going to give us our the height from our cache. And so what we're going to do with that height is we're going to subtract the stored bedrock we have. And then the difference will give us back our sand. It might not look like much, but now if we isolate our sand layer, we should see some sand. Yeah, and so this is the sand from the file cache, sort of reconstructed. And now if we take this and simply feed this back into, we can just do our reconstruction here, which is just the height equals the sand plus bedrock, just the reverse of that formula. And there we go. And if you want to do, again, the visualization is the height field visualization to see the sand. You just kind of plug this in here and compute range and set this to sand. And there you go. And, if you want this to be gray, it's the bedrock. Yeah, you know, change the color all you want. And now you have your cached dune simulation. Okay, I'm going to continue on and show how to do crescent dunes now. Let's turn this off, and I'll go through this again with crescent dunes. So we're going to start with the height field again. We are going to do a copy height field copy layer. And I'll show you, I think I'll do this a little different way. Sand and bedrock. So we're going to take our bedrock from the height, you know, so let's say you have this train. Actually, scratch this. I'm going to start with one of these train tool things. Train effects. So let's add some dunes on the moonscape. Okay. Wow, this moonscape's kind of crazy, actually. Okay, so let's say you got your train here, and you want to add some sand to it. What you're going to do is do copy layer, and first we need to make this the bedrock. So we're going to do source height, destination bedrock. Okay, now we got our bedrock, and you should see it in here. These extra ones were created by the moon. We don't really need them, but they can stay in there. So we got our bedrock. The other thing we need to do is set up a sand layer. So we'll set up a sand layer, and you can see a source of our sand layer is the mask. That's fine. Doesn't matter. That means it's, you know, our mask is 0, so our sand is 0 right now. Then what we need to do is we need to give some value to our sand. So there's a bunch of ways we can do that. We could, you know, do a noise and set our sand that way. I think there's a bunch of other ways too. We could also just I'll just do a wrangle, or let me see actually if there's a there might be a layer, height field layer property, height field layer, file, clip, field layer output. I'm not sure if any of these give you like a super easy way to just have a slider. Oh, I think there's like a clear, layer clear. Yeah, so this is one way you can do it. So this layer clear node, it's called clear, but it will actually just set one layer to be one value. And so we can just say sand, and we can set the sand to be 10. So now our sand everywhere is 10, which generally in Houdini, that's 10 meters, so about 30 feet, 33 feet. And then we're going to drop our Dune Solver. And we can't see our sand right now because it hasn't been added, but as soon as we put this down, we should see our sand. And we got some sand. And if we turn on the colorize up here, yay, sand. And you can see, you know, if we adjust this directly, well, if it was updating, this would directly affect how much sand we have. So the slider. Now we've got a nice little sand slider here. This sand isn't simulated yet, but if we hit play, now we got simulated sand flowing across our what was a lunar surface. You can see we're getting some dunes forming. You can see by default the sand just moves in the positive x-axis. It does have some warping. You can check out the wind trails here. So you can see these are the direction the sand's going in there, or the wind is flowing. And so by default the wind will kind of try and flow around based on your terrain. And we can adjust that down here with these settings. The warp based on height. if you want to change your wind direction, a bunch of ways to do that, but one of the keys is you need to create a wind layer. So to do that, copy height field, copy layers, and we'll call this, we'll use this to make our wind layers. So wind layers are a vector, so it's wind_v.x, and then we need a dot y and a dot z. And you can see as soon as we are feeding it wind layers, now it no longer is going to give us that default wind direction because we're feeding it like a 0 wind direction. And so now the wind's just kind of like, I don't know where to go, and it's trying to normalize from a 0 direction. Easy way to give it a wind direction is to use a wrangle, a volume wrangle, and you can just set this wind direction to something. V at wind v equals channel vector. And again, if you get the Dune setup tool, it makes this like super easy. And you can download that for free. I'm just showing it again how to do this without the Dune setup tool. Wind vector. And hit this, and it will give us a little thing. And now we can give it a, yeah, we don't want any Y. Give it we can change the direction here. And put this back to colorize. And now if we play, the wind's going that way. I think we need to normalize our wind though. It's going a little crazy. Normalize. There we go. That should help. There we go. Got some nice Dune pattern forming. Yes, this I will post this later. I think I'll try and edit this into a couple quick videos. I just figured I might as well try and do this live first. Yeah, so that's that example. I think I'm going to try one more example, and I think this time I'm going to do it with the Dune setup tool. Just as a little easier, and I will also try and show the collision, which is kind of how I did the ball in the sand dunes before. So I'll try and do a setup like that. So start with a height field again. We'll call this dunes ball, and for this, I'm going to go back up here and I will install the Dune setup tool, which you can download this for free, even if you don't buy the Dune Solver. I'm not sure how useful it will be if you don't have the Dune Solver, but you can download this for free at Orbolt. And so if I install this, now I can do setup, Dune setup, and feed this into here. And you can see it immediately colorizes it, which is kind of nice. Excuse me. It's got a whole bunch of settings for like wind. It's got settings for visualizing the wind. Just a bunch of nice stuff. You can set the wind from an angle. You can also set it from a spline, which is kind of handy. We'll do it from angle for now, and set the angle like this. You can also give it some noise. Yeah, I think that'll be good. Sand depth, this is in, units, which are generally meters. I think this needs to be pretty high for this ball example. Try 20 for now. And yeah, this is, you can set the sand on a bunch of different parameters, like, flat bedrock. Flat bedrock, this is, I can show this, I guess, real quick. Height field, noise. So say our height field had some noise to it already. What you can do is set the sand. Then you can say, actually, I want a flat bedrock going across here. And that bedrock, I want any height above that to be sand. And I guess this works better if I center this. Oops. So you can see this is the noise, and then we're saying like flatten the bedrock. Turn off the, and anything above this is pure sand, and then anything below it is bedrock. And so it's just another option, like way to set how much sand there is and what the bedrock is. So you can see if I isolate the bedrock, it's just flat. The other options for the Dune setup tool are you can set it by height mast, which means like over a certain height, don't add the sand. So if you had, so this is only adding sand. This is just adding 2 meters of sand below these height cutoffs. And then in that case, your bedrock is just whatever the height was before. Anyway, it gives you a bunch of fill depth is just like fill this amount of sand everywhere. And I think that's the one that we're gonna go with for this example. So super simple, flat bedrock, flat sand filled to 30 meters, and then we'll do a Dune solver. Oh, oops. I hate that when I forget to put it back to frame 1 and then it's trying to calculate all of a sudden. But anyway, there we go. You might notice, we get this ripple starting here at the edge. There's some ways you can fix that. A super easy way is just make your terrain big enough that you can crop that out. Other ways you can do it, you can do this like loop wind shadow, and that will try and use the dune shapes that are forming over here to affect the shape back over here. Almost like looping, but it only loops it in terms of the wind direction. Let's play it again. It helps a little bit, but it's especially if your height field has any kind of like noise to it, it's not very noticeable. But if it's really flat like this and smooth, it tends to be hard to hide the fact that the sim is starting at this like very defined location. We can turn on the seamless sand, can help sometimes too. Yeah, there we go. The seamless sand will actually try and make it seamless in all directions, which can work pretty well if you're just kind of trying for a fairly uniform like sand pattern. And actually right now I think I'll show how the sand depth affects the different dune shapes. And this is true in real life as well. So let's lower this to like sand depth of 3 from 30. And now if I play it, you should start to see the bedrock poke through, and that will start affecting the dune pattern. Get more kind of, let's lower it even more actually. You'll start getting more crescent dunes, like a different dune pattern here. In the example hip file, if you buy this from Orbolt, the example hip file shows a bunch of different settings and different ways to get different patterns. But yeah, I can see and you can also see how fast this simulates. Okay, back to our collision example. We're going to fill this up, And then we're going to do a sphere. I don't know how big the sphere should be, like 20. I guess it, oops. Maybe 30. Let's place this. And I guess the height, the center should be half of the scale. Copy, print. There we go. And let's make this polygon mesh, or polygon, I guess. Frequency, there we go. A nice sphere. And this part of the Dune Solver is a little bit experimental. So hopefully this works. But basically you can take geometry and you can feed it into this collision objects here. And the Dune Solver will, you can already see it's made like a dent there. It will try to use that object sort of as in its calculations for how the sand moves. And what you want to do, generally these objects are separate from this SOP network. So what we can do to visualize it is like kind of merge it back in if we want to see it. There we go. And let's just try playing this with the default settings. Hopefully I set them fairly well. Yeah, and you can kind of see the wind is being shadowed behind the ball, which is why the dunes aren't forming behind it. I think let's make this 60. It's bigger. Yeah, and let's show you some of the settings here. So the collision settings are buried under this. If you hit plus, basically get kind of some settings about what sort of impact this object that you're feeding it has on the sand. And a round object is kind of one of the trickier ones. If you're just doing a box, it's easier because the profile doesn't change in the vertical. But this gives you some interesting things. So we can show our collision shadow. And so this is basically, because the simulation, is semi 2D, we need to project this collision into this 2D grid. And so this gives us some options for doing that. And you can see as we adjust these, it will adjust kind of the impact that it will have. And then these ramps are for, the shadow ramp is kind of for controlling. So you can see the red here. This is the zone that the sand will get slowed down in. And so that's what this ramp is for. And then the sand ramp is for the carve out, sort of like, so if I adjust this affects like how much sand is built up around this thing. And that's what's affecting this kind of crater shape around it. Voxel size. Yeah, we can show that collision again. Yeah, let's check that. If we want this ball to be sitting more in the sand, what we need to do is not have this sand ramp go down to 0. So we can see this is, if I get rid of the sand ramp, now it's sitting a lot more in the sand. There we go. And you can see this like kind of wind shadow area that's where it's slowing down and not making dunes behind it. That's from, we can adjust that with the wind shadow ramp. I think if we also go to view the wind shadow here, and let's uncheck this. There we go. Now you can really see the wind shadow form from this, and we can adjust this a lot. I think this, is this updating? I don't know. Okay, let's try that. Oh, I see. The part of the problem is the wind shadows forming from that, from this lip. So, okay, let's try and get rid of this lip. Let's kind of clear out the sand from around it more. There we go. Yeah, the stuff's still a little bit finicky, unfortunately. Yeah, this is an area I'm gonna try and work to improve, but let's try and lower the amount of sand here. Should make it a little bit easier. Yeah. This is kind of part of the problem, is it has to rely on, right now it's sampling this as a 2D thing. So it's trying to rely on the biggest area to get the shadow. So one thing you can do is do a peak and bring the collision in a little bit, can help. Try and reset that, and let's go back to a good amount of 10. And then also, if we want this to kind of form faster, we can increase this grain ratio to 1. Should get us some sand dunes real fast. I think also right now might be the height speed up. Let's lower this, and also the height warp. Let's turn off the warps. There we go. Yeah, that's looking a little better. So it's still a little bit finicky with the collision stuff, but can be useful probably still for buildings and different things based on what you're doing. You can still see it's kind of hugging kind of close to there. Can probably adjust this more. I think we need the shadow to fall off faster. Might help a little bit. Maybe we shouldn't go way to no sand. Yeah, I think that's the problem, is we're getting rid of all of the sand under it first instead of letting there be some sand under it. Yeah. Yeah, a ball's the hardest case, unfortunately. There we go, kind of working. Can even, if we make this more iterations, it's like 5 substeps. So now it's really moving. So now we're doing 5 substeps per frame. And one thing to note is right now I have the wind speed up turned down to 0. And what that means is this is going to, the dunes are going to get taller and taller as that happens. Which is kind of a real phenomenon. Like what kind of starts limiting the height that dunes grow to is 1, changes in wind direction, and 2, as the dunes get taller, the wind sweeps across the tops faster, blowing the tops away, which is what the wind speed up factor will do if you turn that back on. But there we go. We got a little something. Yeah, I think I'll make a better video on this collision stuff soon, but hopefully that gets anyone that's interested in it started. Let's look again at this visualize wind trail. So you can see this is the sort of the wind shadow trail being created by that object that gets fed into there. Anyway, I hope that was helpful for people, and I'll do more soon.